Alright, so this is the front and back worksheet from last week. I think it's called AP. At the top of it, it has AP Review Continuous Distributions. And so this is the first question. And all of these, you'll notice that I did not do any of the lengthy z-score stuff because these were multiple choice questions, so I did them the quickest way possible using the calculator. So this one was a little tricky. They told you that 75% of all families spent more than $75, so that's why I immediately labeled $75 and drew 75%. The reason I knew that the mean had to be above 75 is because 50% would have been right at the mean. So if 75%, then 75 must be below the mean somewhere. And then only 15% made more than 150, so it has to be up here above the mean somewhere. So I just estimated where these two numbers were. The fact that they told me the percentages that relate to each one, I immediately then went to inverse norm and found the corresponding z-scores for each of those. So if this is 75% above, then it must have 25% behind it. Now normally I would say inverse norm 0.2, well I did, inverse norm 0.2501, and it gave me the corresponding z-score of negative 0.6744. So these numbers up here in terms of dollars, raw data, and these are the corresponding z-scores. And then I did the same thing here, except for 15% above it's going to be inverse norm 0.85, and its corresponding z-score was 1.0364. Now, they're asking me to find the mean and the standard deviation. So now I know two raw data values, two x's, if you will, and I know two z-scores. But if I go to this z formula, I know the x value, the amount of money, and I know the corresponding z-score. I've got to find the mean and the standard deviation, or at least one of them, to be able to find the other. So all I've done is I've figured out the difference in money in relation to the difference in z-scores, because these are the same exact locations. And so this distance is proportional to this distance. And so I just took 150 minus $75 on top, a difference of $75, and then I took this z-score minus this standard deviation minus this standard deviation, gave me a difference of 1.7108 standard deviations. Well, I don't want to know $75 for every 1.7 standard deviations. I want to know how many dollars for every one standard deviation. So all I did was just divide the top and bottom by 1.71, or just 75 divided by 1.71, and that tells me then for one standard deviation unit, it is a value of $43.84. Well, now that I know the standard deviation, I just went back to my z formula and I picked one of these numbers. It doesn't matter which you pick. I picked $150 and I put it in for x. I put its corresponding z-score, 1.0364. I still don't know the mean, but now I do know the standard deviation is 43.84. And now it's just a matter of solving algebra to solve for the mean. And so the mean is $104.56, which I don't even know that I wrote down the letter. It must be D. I don't even think I put the letter up here. Yeah, D is the correct answer. Alright, number 2 is a little tricky because at first what I did immediately when I heard the middle 95%, I thought about the 68, 95, 99.7 rule, and I knew that that was within two standard deviations of the mean. And so I added 1750 twice and I subtracted 1750 twice. And I forgot what I got, but I didn't get exactly what the answers had. I picked the one that was closest to it, and it was B. But then I actually went back and calculated it correctly, specifically to see if I could make sure that I zeroed in on the right answer. So if this is 95%, then this is 5 on either end. So this is 0.025 on this end, 0.025 on this end. So I just did inverse norm, 0.025. I didn't bother doing 0, 1 because it's a multiple choice question. I wanted to know the actual dollar value, not the z-score. So I actually plugged in what dollar value lies with 2.5% behind it, with a mean of 9,500 and a standard deviation of 1750, and that was this bottom number. Then I did the same thing, except on top it's not 0.025, it's 0.975 behind it. But again, I just went straight and used the mean and standard deviation of the raw data, and it gives me the raw data answer. Again, if this was a free response question, you would need to do inverse norm 0.02501 and actually get the z-score, then use the z-score formula to show how to get back to the raw data. But since it's multiple choice, we're going to take the easiest way out we can, the quickest way. And so, in fact, it was B that was the best answer because that's the closest to this. So that 68, 95, 99.7 rule is a rough general estimate of about where 95% lies. It's not exact, and so that's why this is a little off from when you do just adding 2 standard deviations and subtracting 2 standard deviations. You get a little bit different numbers. Hang on a second. Okay, so number 3, the noise level in a restaurant is normally distributed with an average of 30 decibels and a standard deviation of 4, and all they wanted to know was 99% of the time it is below what decibel value. So again, since I know 99% of the time we wanted it to be below this value, I knew this value had to be above the mean, and so I just simply did an inverse norm. And again, if it were open-ended, I would have done inverse norm 0.9901 and convert it back, but since it's multiple choice, I just did inverse norm 0.99 with a mean of 30 and a standard deviation of 4 is going to give me the actual number of decibels that correlates to that number or that value, not the z-score. So 39.305 was the correct answer, and so our answer was E for number 3. So that was just a simple inverse norm problem. Number 4, average of 3.4, it's normal. 0.5 is the standard deviation. All right, and what is the probability that an item will take between 3 and 4 hours to go through the line? The probability is just the likelihood or the area between these two values. So whatever percent of the time lies between 3 and 4, then that is the probability of that as well. And we haven't really talked about that a lot. So all I did was just not inverse norm. I knew my boundary points, so I said I want to know from starting from 3 hours and stopping at 4. So norm CDF, start at 3, stop at 4, the mean is 3.4 hours, and the standard deviation is 0.5 hours. And so this area is 0.6737, so that is also the likelihood that it would take between 3 and 4 hours, which is letter E. Now, the rest of these, I don't have the questions here, but we're just going to talk through them. Number 5 says, which has the larger mean and which has the larger standard deviation? Well, first of all, they're both on the same continuous number line. So the mean of A is somewhere around 1, 2, 3, 4, 5, around the 6th little tick mark over possibly. And B, if you keep on counting, is on up above that. So it's on the same number line. So B's mean, its middle peak point, is going to be higher than A's peak point. So B definitely has a larger mean. Now when you start talking about standard deviation, that is spread. So from its mean out and from its mean out. So for A, its spread is definitely wider. So its standard deviation is much bigger. So C is your best bet for number 5. Number 6, B is the correct answer. Which of the following statements is false? All bell-shaped curves are normal distributions for some mu and standard deviation. You can't just use the normal distribution curve or functions if all it says is it's a bell-shaped curve. Later on we'll get into that and we'll assume it's normal and we'll check for normal conditions, but right now they have to tell us it's a normal distribution. Just because it's bell-shaped does not imply that it is normal. A, the mean and median are the same if it is perfectly normal, and pretty much 99.7% of the data is within 3 standard deviations of the mean, and that's true too. 95% of the data usually lies within 2 standard deviations, and then the 50th percentile of a normal distribution is the mean of the distribution, and that is correct too because the mean represents the bottom 50 and the upper 50. So B is the only one that is not completely true. Number 7, a z-score is called a standardized score because you can, and this might have been kind of tricky for you, but the reason it's standardized is that, remember when we talked about somebody's score in one chemistry class where the mean was 80 and the standard deviation of 5, but somebody else's score could have scored the same score, whatever it was, in a different chemistry class where the mean was 90 and the standard deviation was 2. And so in order to compare those 2 different distributions and figure out how they did in relation to the rest of their class, we standardized them. And so that was E. You're going to convert them to a universal standard, and so that you can compare 2 different standard normal distributions. So that one might have been a little hard, but you're trying to get them all on the same like playing field, so that in terms of the same terms, so that we can compare them. All right, number 8. I just kind of like the ones we did on the last little test at the bottom. It's a uniform distribution, so the fact that they told me it was uniform, I just kind of sketched a rectangle. They told me the range, and so they also told me that the median was 72. Well, if it's perfectly uniform, the mean and median are the same, but the median's right there in the middle. And so I just figured out if the median was 72 and the the range was 46, that meant it was 23 above and 23 below 72. So that meant it went from anywhere from a 49 to a 95. Well, they're asking me what percent failed. That means anything below a 70. So I just figured out how much distance there was between 49 and 70, which is 21. So 21 little sections out of all 46 sections is the percent of the class, or the proportion of the class that failed. And that would have been, I'm looking at the wrong one. Yeah, A, which is 0.4565. I was looking at another A that said 0.5, and I was like, that's not right. But 8 is right. 21 out of 46 is 0.4565 of the class failed. All right, so the rest of these are also just kind of talking through them. Number 9, areas, and so the answer for 9 is D. Which of the following are true? All right, so A is saying the area below the mean is greater than the area above the mean. We know that's not true. It should be 50% on each end. The area is the range, or from 0 to 1 on a z-score is the same as 1 to 2. That is not true. That's only true if it's a uniform distribution. Roughly 50% of the observations are located at the mean of the distribution, and that means it's at the mean. No, it's 50% below or 50% above. And then D is the correct answer, because we know that 99.7 is between -3 and 3, so 0.3 is, or 0.15 is on either end, so that's definitely less than 1%. Number 10, I'm going to have to get back with you on. I kind of got it just by kind of reasoning through that, but I'll have to look to see if there's a way we could have actually calculated that, and I have not taken the time to work that one, but I'll get back with you on that one. 11, which one's about a uniform is false. The area below the mean is greater than that above the mean. If it's perfectly uniform, the mean and median are the same, and if it's perfectly uniform, like the one that we did up there above, it should split it equally in half, and so the area below the mean should not be greater than that above the mean. B is true, because if it's uniform, the rectangles from 0 to 1 is the same size rectangle from 1 to 2. Mean and median are always equal if it's perfectly uniform or perfectly symmetric. The rest of those are right. 12, which of the following is the least likely? It's the automobiles. You would not have, we would think that would be the least likely to be normal. I'm not going to go into that. I'm not so worried about you. They're going to be completely obvious if the ones that we're going to have to do, so don't worry too much about 12. I don't really think that's going to be a problem. All right, 13 is one I do want to talk about right quick. I just drew both of my distributions of A and B and labeled the mean and standard deviation of each, and then I just calculated everything they asked me to do. So the area below 25 in the population A, I just went from the lowest I could imagine, which would be 0 to 25, with mean 50 and standard deviation 12. And that was the area that I got. Then I did the same thing for the area above 65. I did that for each one of those, and the one that turned out to have the greatest proportion was E on 13. 14, all of the following would be evidence that you do not have a normal distribution. Multiple modes would be more than single peaked, which is not a normal shape, so A would not, that would prove you don't have a normal distribution. The fact that 75% of the observations have a value below the mean, that would not be true either, because 50% below, 50% above, so that would also indicate it's not normal. A normal probability plot, that's the one that we didn't talk a whole lot about, but the normal probability plot should fall in a straight line if it's linear. So of course if it's curved, then yes, that's a clue that it's not normal either. And the likelihood for all values of x is the same. That would imply that it's a uniform distribution, and that would mean not normal either. So E, none of those. They are all ways. And then 15, I scrolled back up. 15 is one that you couldn't do either. 15 is actually a binomial distribution. I don't really know why it got stuck on this worksheet for continuous distributions. It is A, but we will get into binomial distributions here shortly, so that one you did not know how to do either. So 10, I still need to check on and work through that one, but otherwise that's the rest of those solutions.